Well, hi again. This is Ralph Resnick, the founding director of America Makes, and welcome to another session of America Makes Game Day. Here I am going to be talking to one of my all-time best buddies, Slade Gardner. Slade has been a pioneer in additive manufacturing and is constantly doing new things and pushing the boundaries. So Slade, why don't you tell us a little bit about your background and what got you into additive?
All right. So before I do that, let me just say that the weather here is perfect for additive manufacturing. We have bright lights coming out of the high efficiency lighting. We've got perfect temperature in here. The turf is even perfect for additive manufacturing today.
Absolutely.
So that sets us off
Absolutely.
for
Who do we think is going to win today?
Well, I think we're all going to win a little bit here,
Yeah?
Ralph. I think we're all going to win.
Outstanding.
Yeah.
Okay.
So what got me into additive? You know, I started my career in traditional composites, and I was building prototype composite structures for JSF, for F-35, and thinking about manufacturing of the future. And really the thing that I loved so much about traditional composite manufacturing was the collection of material science, mathematics, and manufacturing processing that went into traditional composite manufacturing. It's really math intensive. Materials are definitely important, and the way that you put these materials together is critical to the way that they perform. And then I learned about additive manufacturing. I learned about 3D printing. It took all of those elements that I was so attracted to, and it added the need for computer programming, for modeling and simulation. It also offered the perfect exploration ground for Industry 4.0, because when you're doing manufacturing development, one of the hardest things for you to do is to give your workforce a process run sheet and have them follow it precisely.
Exactly. Yeah.
But the motion control in the robot does it perfectly. It does exactly what it's asked to do. So all of a sudden you have the perfect exploration ground for doing manufacturing development, material development, process development, all with a mathematical foundation. I was hooked.
There you are.
Yeah.
And so you worked at Lockheed Martin Skunk Works.
Yep.
And Lockheed Martin Space Works, right?
Yep.
And we're bringing additive manufacturing into these advanced systems. What are you doing now?
Well, my last gig at Lockheed Martin Space, I took 3D printed titanium propellant tanks from the laboratory and delivered it to the factory for commercial adoption. And large 3D printed titanium propellant tanks are now accepted for that commercial program. It's a huge achievement. After that, I was so excited to be able to do that sort of thing for more and more customers. One of the things that I learned while I was doing 3D printed titanium tanks was I had to figure out everything on my own. I didn't have anyone that I could call and ask questions or get assistance with, whether it's materials development or process development, whether it's equipment development. I didn't have anyone that I could lean on for answering those questions. I had to figure it all out myself. So I decided that's a good place to start. So I started a company called Big Metal Additive, and that's what we do. We help our customers do design development, prototype articles, and also learn how to do large metal 3D printing. Big Metal Additive is focused on aluminum materials right now, and we've developed a hybrid additive manufacturing technology that's quite unique. It deposits metal, and then it surface machines every layer. That's so important for quality. It gives us a perfectly defined layer height for every layer of deposition. That eliminates tolerance mismatch or defect stack up in the overall part. So our parts are built with dimensional stability. But the other thing that does when you machine every layer is it gives you a clean, flat, smooth surface for every diffusion layer. And that's important for quality. When you're going metal to metal joining, the first thing that you want is an oxidation, debris, contamination-free surface. And when we machine that surface, that's what it gives us. So we've got a table, a machine that has a 6-foot by 12-foot table. We can 3D print things
Wow.
as large as a car chassis on
Yeah.
that table.
Yeah.
And we're pioneering this space of metal 3D printing.
So are your materials anisotropic?
They are to a large degree. We're getting our mechanical test data. It's in the lab right now. We'll
Okay.
know for sure. And we're getting test data in different directions, and so we'll know whether they're anisotropic or not pretty
Yeah.
shortly. We have pretty good confidence that, and I'm leaning on the work that we did with titanium in the aerospace industry, we have confidence that they are going to be isotropic and that we're going to get good consistent material properties regardless of the direction of loading.
Excellent, excellent. Well, that's part of the Holy Grail, right?
You bet it is.
Yeah. So, so are you open for business?
We're open for business.
Cool.
We are.
All right. So if you want to contact Slade Gardner and Big Metal Additive, he's the man. So so congratulations. Good luck to you, sir.
Thanks, Godfather.
All right. Bye.